Hello, everyone. Welcome. I hope you are all doing great. We are going to kick off our webinar. So I'm David Gurlé. I'm the founder and chairman of Hive. On this very special day, February 14th, I wish you a wonderful Valentine's Day. And I hope either you had or you're going to have a great time with your loved ones. Today is a very exciting webinar for me for a couple of reasons. Number one, we're going to cover a topic that keeps coming back every time I have a chance to talk to either a user or an investor. And this topic is about how do you make the data available on a network while that keeps changing its structure all the time. And we're going to have some interesting review of what we are doing on this one. And the second is actually, this is Antoine's first webinar and in our third webinar of this series that we started late last year. So without further ado, let me introduce you to the speakers today. So beyond the introduction now and moderating the Q&A session, I'll be giving the floor to Antoine, who will take us on the agenda and then the rest of the talk that we're going to give today. And then Adnan, he is our front-end engineering lead, who's going to take us on some of the details that we are very excited to share with you. So without further ado, Antoine, the floor is yours.
Thank you, David. Hello, everybody. I'm Antoine Cloget, the CEO of Hive, and I'm happy to welcome you to our third webinar, which is my first webinar. Today, we will indeed be digging into a very important topic. How do we guarantee data safety and availability on Hive? It is a question that we get very often, and you will see what happens to your data behind the scene that enables us to provide the good experience and safety you expect. So I will start with a quick reminder of what is Hive, what is hiveNet, what is Hive Drive, and then Adnan, our R&D lead, will explain how we keep your data safe and available. I will then do a quick update on what's coming up on Hive Drive, the application we have today running on hiveNet, and David will moderate the Q&A session. So let's have a look at what is Hive. For those who haven't followed us so far, Hive is a distributed peer-to-peer cloud that federates and weaves the unused resources of computers. Today, we estimate that half of the capacity sitting in your laptops, mobile phones, home servers is unused. By sharing these resources and pooling them together, we are building a virtual cloud. Using this cloud infrastructure, we will offer compute and storage services. So basically, this is a cloud without data centers, and it provides a number of benefits. It is decentralized. Your data and your workloads are hosted by the community, not only by a handful of players, and it respects your privacy. And moreover, it's more sustainable. There are no data centers, and these data centers are huge energy gluttons. Let's now see what is hiveNet. hiveNet is the name of our cloud infrastructure. It is built by our user community. We call our users Hivers. And this infrastructure relies mostly on the resources that you, our users, share. The user devices are shown here as user nodes in the network. And data on hiveNet is exchanged directly between users using peer-to-peer technologies. We may add a few other nodes in the network. They are exactly like user nodes and are here to help improve the quality of service of our network. We call them helper nodes. As you will see, we will build multiple applications on hiveNet. The first one is called Hive Drive. Our first application, Hive Drive, is a secure and private file storage application. Like other cloud storage applications, you can store your files in the cloud. But with Hive Drive, in terms of resources, what you share is what you get. If you share 50 gigs of your own space, your own drive, you will get 50 gig on Hive Drive. It's completely private. Nobody, including Hive, can access your encrypted content. Your content may not even transit through Hive servers. It's also sustainable. We used existing devices when they are powered up. So no, you don't need to keep your computer on and connected to HiveNet to contribute your resources. And Adnan will explain how it works. We will build many other applications, not only in the area of secure storage, but also compute. HiveShare will come next. It will enable you to share your files of an unlimited size on Hive. Hive Vault will provide a secure vault for your highly sensitive data. Hive Compute will enable you to run compute workloads on HiveNet, and many others will come. These will come soon, so stay tuned. We are very happy to build Hive together. We've had many Hivers joining recently, and we now have 750 Hivers forming HiveNet. I'm absolutely amazed to see the interest across all continents. We now have Hivers present in 50 countries. We recently welcomed Hivers from Romania, Qatar, Mauritius, and Greece. Let's now see how we make your data safe and available on Hive. And without further ado, I'll leave the floor to Adnan, who will explain how it works behind the scene.
Thank you so much, Antoine. And hello, everyone. I'm Adnan, engineering lead at Hive. So as we've seen with Antoine, Hive is a peer-to-peer system, and one of its major properties is the node dynamics, or what we call churn. Participating devices can be joining or leaving at any time. So in this session, I'll be explaining how data in Hive is always available and ready to be downloaded just like any centralized cloud storage solution. Now, let's consider the following scenario where we have one file of 1 megabyte we want to upload to Hive Drive, and 8 devices we'll call D1 to D8. Now, we'll start by using replication protection, okay? So if we take our file and split it into 4 pieces, call them P1 to P4, then duplicate each one of these so we can distribute them across the 8 devices. So this way, P1 would go to D1 and D5, P2 to D2 and D6, and so on. So here we use the replication factor of 2, and our system is capable of supporting a failure of 4 devices, but only if all the pieces can still be accessed. A failure of D1 and D5, for instance, would prevent us from retrieving the piece number 1 of the file. Well, this is not ideal, right? So to overcome this situation, we'll be using a technology called erasure correction coding, or ECC for short. So ECC is a method of data protection in which data is broken into shards, expanded and encoded with redundant pieces of data called parity shards, which are then stored across different nodes. Now, let's say that some devices fail or disappear or data becomes corrupted. We can still reconstruct the full data from all the shards stored in the remaining devices. Basically, you can see ECC like a Sudoku board, where the encoded chunk corresponds to the fully filled Sudoku matrix, and each cell corresponds to a shard. Given a minimum set of cells, all the empty cells of a Sudoku matrix can be calculated and filled up. So now let's get back to our example of one file with 8 nodes and still the same replication factor of 2, but this time with ECC. Even with a failure of 4 nodes, we can still reconstruct the whole file. All right. Now, I'll try to make it even easier, and I'll explain how ECC works with a real-life demo. So to simplify, we'll use a Hive swarm of 5 nodes, okay? So the 4 nodes you see in the top are going to be receiving shards from the user node in the bottom when he starts uploading his file. These nodes are using a custom version built for demonstration purposes of Hive Drive, capable of showing a notification when they store new shards. So first of all, the user will start by uploading a file. And while the file is uploading, we'll see what's going to start happening. Now, you'll see that the apps are showing notifications each time they receive shards they need to store. You can see several notifications as the content gets dispatched on the network. All good. The upload is done, and now we'll start simulating some node dynamics for this. First node will be disconnecting from the network by closing the app. So now the node disconnected, and behind the scene, we make sure that all the cache have been cleaned up, and we'll try to download the file. As you can see, the user can still download his file as there are enough nodes in the network. Now let's repeat the same operation by removing one more node from the network. And we're at a node availability of 50%. With ECC, we'll be able to reconstruct the rest of the file as explained before. Now let's push it a bit further and remove one more node from the network. And let's try to download the file again. All right. Well, as you can see, the user can't download the file anymore as there aren't enough nodes over there. Okay, I see you coming. You're going to tell me, Adnan, what do we do now? I still want to download my file. Well, don't worry. The solution is called swarm healing, and I'm going to walk you through it next. So taking all what we've seen so far, let's start the whole operation of uploading a file from scratch. First of all, the file gets split into multiple parts called chunks, and each chunk is compressed to reduce its size and encrypted to secure its content. In order to make the data reliable and tolerant to losses, we now encode it using ECC. The sharding and ECC processes are done in a way that allows the recalculation and retrieval of the original chunk from any minimum subset of the generated shards. Now that encoding is done, we have a set of shards that need to be uploaded on the Hive network, and we'll find the most appropriate nodes for hosting the data. The selection of nodes is based on multiple criteria, such as the reliability score of the node and its location and its available capacity. And as we go, other selection criteria, such as the energy consumption, will be considered as well. So the selection process will also ensure a certain diversity and complementarity across the storage nodes. So if a disaster hits a geographical area, or if a failure affects an energy or network provider, only a small fraction of the storing nodes gets affected. This way, data stays available thanks to the remaining healthy nodes. The shards are simultaneously transferred to the selected storage nodes using the IPFS protocol. So as I said before, one of the major properties of a peer-to-peer system is its nodes' participation dynamics, or what we call churn. Nodes can be joining or leaving the network at any time. And to deal with it, the HiveNet keeps monitoring the availability of the data and their associated storing nodes. If the number of available shards for the same chunk goes below a minimum safety threshold, new shards are regenerated and stored on new nodes. In this example, we have some nodes that start disconnecting from the network. Here, although the data is still retrievable, the network will trigger what we call a swarm healing process. So the healing process generates the missing shards thanks to ECC. And as we've seen before, and as in a Sudoku board, getting to know just some of the shards, we can reconstruct the missing ones. This process will be handled by the nodes hosting the remaining data in the network, and they'll need to select new nodes around to host these newly generated shards, and so on. The swarm healing process is triggered each time the number of available shards goes below a certain safety threshold. And here we go. Now you know everything about how we make sure your data is always available. And back to you, Antoine.
Thank you, Adnan. It's great to see how we can build a cloud with high availability while not asking our users to keep their devices always on. Let's now have a look at the roadmap. We are improving our first application, Hive Drive, month after month. We took into account some of our Hivers' feedback. You can now select the folder from which you want to contribute free space. And we're adding many other improvements to our setting and preferences screen. We're also completing some missing actions like copy and paste folders. All these file manipulations will become even more natural as we integrate seamlessly with the Windows File Explorer and Mac Finder. Next month, as you see, we will also ship our first mobile version on Android. And if you're curious like me and you want to see hiveNet grow, we will soon have our live interactive HiveNet map. So I hope many of you will want to try Hive Drive. So how to download Hive Drive? So the best way to know more is to download the Hive Drive application on our website, hivenet.com. All you need to do is to contribute 5 gig to start, and we always welcome your feedback. So I hope you enjoyed the session with us today. We've presented HiveNet, our cloud infrastructure powered by our community, and Hive Drive, our first application for private file storage running on HiveNet. Adnan explained how we guarantee the safety and ability of our files, which is often a concern our users have when they hear about our community-driven cloud. I hope we convinced you that your files are safe with us. So follow us and visit us on hivenet.com, and let's build Hive together. And I will now hand it over back to David for our Q&A session.
Thank you very much, Antoine, and thank you very much, Adnan. And also thank you very much, Amin, in helping us to put together all the technology that enables us to give such availability to our Hivers. If you have any questions, we have a Q&A button at the bottom of the Zoom webinar screen. Just hit it and ask your question. You can do it anonymously or you can do it in person. And I'm now going to try to dispatch the questions to the team. I'll start with the first technical one. I mean, this one is for you. Actually, it's a very good one. What if you reach or exceed the ECC correcting ability threshold? Is there any way to retrieve the data? Is there any condition to improve the redundancy level to avoid this scenario? Is it based on amount of memory a user shares, for example? So, I mean, this one is for you.
Yeah, thank you, David. So, hello everyone. Indeed, very, very good question. So, yes, today, if the number of available shards go below a certain threshold, we'll not be able to retrieve your data. But don't worry, as Adnan explained, the swarm healing process has been implemented to prevent this situation. Basically, we have a safety threshold, which is above this minimum threshold. And each time the data, the number of available shards goes below the safety threshold, we will regenerate new shards and disseminate them across the network. So we will never meet this situation where there is no, where the number of available shards is will not allow us to reconstruct your data.
There is a very quick follow-up question, which I would have asked as well. So what is the safety threshold to trigger the swarm healing? You know, at one point we trigger it so that, you know, we heal the lost bits in the network.
So, okay, so today the minimum threshold is 50% of the data, and the safety threshold is set to 75%.
Yep. And you know, we are obviously keeping statistics of all the user nodes going up and down. And one thing that is really interesting is that actually the nodes actually go down. I mean, we definitely see the pattern up and down, and it's time based, and you can see actually you know, different time zones taking their computers down versus the other time zones getting their computers up. And what's really fascinating about that, and Adnan mentioned this, is that we have a node selection process. Today, it is not extremely sophisticated, and we are obviously making it more and more sophisticated release after release, but we can actually use that you know, on and off technology of people's taking their laptops up and down, for example, to distribute the data as well. Let me continue. Another question is, what type of nodes are in charge of swarm healing? Will they scale when the network grows? I mean, you want to take this one as well? It's very technical.
Yes. Indeed, a very nice question. So actually, the swarm healing is a distributed process and is handled by two types of nodes. We will have healing controllers and we have healing workers. The healing controllers are high available nodes among the Hive nodes or the helper nodes, and these nodes are responsible for maintaining a map of which node is hosting which shards. And these controller nodes will keep monitoring the availability of all the other nodes. And if we detect that some nodes go down and that the number of available shards goes below this minimum safety threshold, this controller node will spawn some repair jobs on the worker nodes to recalculate the missing data and disseminate this data across the network. So the process is completely distributed and controlled by this healing controllers, and the job is done by this healing workers.
Excellent. I have like a ton of questions coming. Let me switch to another one. This one is going to be for Antoine. Antoine, we have a question about our business model. Well, it looks like, what you share is what you get. Therefore, how Hive is going to make money.
Okay, yeah, that's a very common one. Indeed, today, what you share is what you get, and so it's free. Moving forward, obviously, there will be some of our users on hiveNet that will ask for more capacity, and some users that will want to share more capacity. And we will then have a transaction between the users that consume more than they get and users that actually contribute more than they use. And we will take a percentage above that transaction. So what we will introduce these new models middle of the year, and that is based on, we're going to base our business model on that.
So basically what you're saying is that if you consume more than what you share, you'll pay something. If you consume less than what you share, you get paid. And Hive facilitates this transaction among the peers and takes a percentage of cut to enable that matchmaking. Correct?
That's exactly it. Yes.
Excellent. I mean, I got such great questions ahead. I don't know which one to pick. We have a good question. Somebody wants to build on our platform. We have Hive build that we talked on our webpage, but we haven't talked about that. So when are we going to open the platform of Hive so that third parties can actually build their applications on Hive?
So we indeed did mention Hive build as part of the coming applications. So Hive build, we plan to release that towards the end of the year. Where we will open, more our APIs so that people can build distributed apps on HiveNet. Now, I'm very curious about what applications, our users right now want to build on HiveNet. So, if this user wants to reach out to us and explain us a bit more what he intends to do, we can definitely discuss that further and see, what we could do earlier than second half of this year.
Excellent. Well, I don't want to anticipate the name of the person who asked the question, but feel free to reach out to David at hivenet.com or Antoine at hivenet.com, and we'll be more than happy to take the conversation forward. I just want to make sure that you know that we have built API first in everything that we've done. So in other words, we are ready, natively to build, to allow third parties to build on our infrastructure. There is another question I really like. Do the nodes that are in charge of generating new shards need the encryption key? I mean, I think that one is for you.
No, it's absolutely not needed. So actually, these repair nodes work on encrypted chunks, and they don't need the decryption key to regenerate new shards. So the design has been made so that this key is only needed by the owner of the data when he needs to download this data.
Very good. There was a question about performance being very slow. I'm the one to complain about that too. Maybe Adnan, you want to take this one? What are we doing to improve the performance for uploading and obviously for downloading in the coming releases?
Yeah, so we're tackling the performance issue from different angles. Today, the original algorithms we worked on to upload or download files were done in a kind of synchronous way, which makes dispatching into the network done in a certain with a certain cadence. And today, actually, what we're trying to do is improve into parallelization of the tasks ongoing. So every upload and every dispatching into the network happens in parallel, and this way we can have a better speed while uploading and also while downloading the files.
So this is what we call the asynchronous upload and download, but we are going to do more. You know, we're going to add multi. You know, we talked about some of the other technologies we're going to deploy over the coming releases. I don't know whether you know, you, Antoine, or someone else wants to share this, so that, you know, we reassure, myself included, and obviously our hivers, that we're going to be blissfully fast. You know, actually faster than centralized systems.
Yeah, definitely. I think their performance is something that has a number of ways to be dealt with. So we mentioned the fact of being asynchronous is, at least, you know, we don't have the user waiting for an action to be performed. There is the fact of parallelizing the number of tasks. The more nodes you address and download at the same time, you can actually get a better performance than if you were to download it from a single server. So actually, peer-to-peer technologies have shown great performance. And then there are multiple optimizations that you know, we are currently working on to get to even better performance than what you could expect today on standard centralized cloud storage applications. So performance is definitely a key user experience factor that we want to continue working on for the months and quarters to come. So look at the performance. It will improve release after release.
I can't wait. There are two questions I'm going to take myself. The first one is, are you thinking of providing services to businesses, companies, so they can create their internal shared networks? If so, at which point in time? The answer is absolutely yes. Actually, you have to think of Hive as a set of federated swarms. So I think of that in the spirit of what internet was meant to be when it was created, and I would say at the IP layer, it's still the case. And so we think of Hive as a set of autonomous networks, and that will interconnect with each other. You know, we are building the one that is public one, but you know, I'm assuming that, you know, if we go into a territory like China, they may want to build something that's completely their own, as opposed to be, you know, allowing in and out the traffic, you know, without a proper surveillance, because sovereignty is an extremely important one. And the same is true for a smaller organization, and they also want a private network too. So we will cater to this, and we will cater to this year. I don't really have a particular date for which, you know, we will deliver this capability, but it's definitely a this year roadmap. The next question is there a sort of service provided so that somebody that loses his or her key may get back their data, or is it forever lost? So today it's forever lost. I wish I could give you a better answer than that, but it is forever lost. That's the price of the master password that we ask at the beginning of the sign-up process. Having said that, we are soon bringing mobile capabilities, as Antoine mentioned, to Hive. And so the idea is that through the biometric authentication systems of your mobile phones, whether it's Android or Apple, you're going to be able to find a way to retrieve this password, and you don't lose that data. And Amin is actively working on this to make sure that it is super secure. And so that is something that we intend to do before the end of the year as well. So there were another question about, let me just see. Yeah, there's an interesting question. I'm currently connected to 33 nodes across the world. are they the only ones available at the moment, or did you set up a limit about the number of nodes to be connected to? Amin, do you want to take this?
Yeah, sure. So actually, there is no limit in terms of the nodes you are connected to, but this number depends on your network conditions. It depends on the box, your internet box you are connected to. In some situation, when you are behind the net, a certain type of net, implementation of net, you may not able to connect, to establish a direct connection to other nodes in the same situation. But don't worry, so this limitation is only on, let's say, the discovery process. When you will need to upload your data, eventually we will find other nodes and we will find a way to establish a direct connection to these nodes so that you will be able to upload your data on many more nodes.
Yeah, I personally went all the way up to like 70 nodes connected at one point. And it varies, you know, right now I'm at 37 and I'm right now in Hong Kong, actually. Let's continue because questions are just so good. Does the algorithm, I'm assuming that's the swarm healing algorithm that we are referring to here, assigns different thresholds depending on how often do we download certain files with respect to others, so that the files that are used more frequently have more chances of being available? So I think, is there a form of caching? I think that's what the question underlies. I mean, you want to take this one?
Yeah, sure. So today we are applying the same replication factor on all your data. This being said, if you download your data on one of your devices, your data is being cached in your device, and accessing your data another time will be much more faster, and you don't depend on other nodes to retrieve the data you have accessed previously, thanks to this caching property of our system. So this being said, I want just to mention that in upcoming releases, we will have what we call the offline mode, meaning that if you have accessed your data previously, you will be able to access the same data, even if you are offline, if you are not connected to the network.
Excellent. We have one participant who would like to dig in further to the swarm healing process, which I think is a good question. So I'm gonna dig even more. We see, you know, he thanks us for our answers, and suggests that even with that swarm healing, there is a risk of losing data because we obviously cannot guarantee the availability of the nodes, which is the characteristic of our infrastructure. So the storage process, as described, is based on the availability of nodes. I believe, the person says, that the storage process will rely on more parameters, such as security location rating, and obviously on the nature of the storage nodes, public cloud or private cloud. So I think the question is that what happens if worst comes to worst, right? You know, is there a threshold under which data is lost, or you know, do we find a way to still cope with that situation, you know, based on some other parameters that we put in the algorithm for swarm healing? Who wants to take this one?
Yeah, I will take this one. So basically, as Antoine mentioned, we have what we call the helper nodes in our network. And in this category of nodes, we have two subcategories. We have the storage nodes and we have the super nodes. So the super nodes are here just to improve the connectivity and the quality of our network. And the storage nodes bring a kind of elasticity into our storage capacity, so that if there are no enough nodes in the network, Hive will automatically spawn some additional helper nodes, some additional storage nodes to deal with this extra demand. And obviously, these nodes will be scaled down when other nodes will come to the network.
So basically, what we are saying is that we have basically built an autonomous process that adds number of Hive helper nodes, as Antoine mentioned in the description of HiveNet, to cope with a situation where things really come to worse situation. And they are the same type of nodes that we used to use when I was running Skype for Business, which was also a peer-to-peer network, which we call super nodes. And the super nodes will come online and just make sure that they can resolve basically the address resolution and viral traversal protocols that were needed for voice protocol exchanges. There is another question that I need to immediately answer is, do you assume that the keys are stored somewhere? So we are talking about here the master password. And you talked about capabilities to get this key, basically recover this key in the future. If that is so, it could be a huge security issue. Don't you think so? So number one is that the key is only stored in your password chain in your local computer. So it's not at all distributed to any other place that Hive actually has access to. So that's the reason why today, when you sign up into Hive, we make sure that to repeat again that if you lose it, it's toast. But I mean, what happens in a situation where the mobile device comes in and we use the mobile device biometric capabilities in order to regenerate that master key in case the user has lost it?
Yeah, so basically your data is encrypted with different keys, and the keys are organized in an hierarchical way, meaning that to access key n, you must have the key n-1. And the root of this hierarchy being your master password, which never leaves your device. Okay, so to be able to decrypt all your hierarchy, you absolutely need this master key. So this master key is is not supposed to be lost. And with this new type of devices, the mobile devices, we have some hardware encryption capabilities that are able to store, to save some critical data in a kind of encrypted memory. And this memory is decrypted only by using some biometrics, your fingerprint or your face, or just by putting your PIN code. So only you, using your biometrics, will be able to unlock this memory, this storage memory, and retrieve this key from this device.
Thank you. I mean, that's obviously reassuring, because that's an absolute must for our users, and obviously it's a core philosophy of Hive, which is absolute privacy. I just want to remind everyone that we not only encrypt the data, we also encrypt the metadata. So that's very important, because nobody also can see what's going on just looking at the envelope of the data that encapsulates your files. There's a very good question attached to this encryption key, master key. Do we need to share the master key to share a data with a private group of users? So, Antoine mentioned that we're going to bring Hive Share in Q2. He didn't say Q2, damn, I just said it's Q2.
I said
okay.
soon.
Said soon, yeah, I'm just okay. Well, it is Q2, huh? So how can we share the data with actually people who don't have my master key?
Okay, so good question. So basically, you don't need to share your master password to share a file. So as we mentioned, each piece of data on Hive is encrypted with its own unique key. And as we said, these keys are stored in a hierarchical way. Each level encrypts the next level of keys. Okay, so if you want to share a file, basically what we do is that we will retrieve, or you will retrieve, the key used to encrypt this file, and you will encrypt this encryption key with the public key of the user you want to share the data with, so that only this user who has the private key associated to this public key will be able to decrypt the key that will be used to decrypt the file you are sharing. I know it's not that obvious, but maybe it could be a topic for our next webinar.
I think a few
I like
diagrams
it.
in our next webinar will help.
Okay, I like it. That's a great idea. Questions are, I mean, we received so far like 28 questions, so I'm trying to go through all of them. But I mean, soon we're gonna run out of time. But I think they are so good questions. Which one? There's a question about the famous bonus, right? You know, if you share 50 gig, you get 2 terabyte back. And so there was a time in which we made this offer. It expired on January 31st of 2023. If you have actually downloaded Hive Drive during that time, so until January 31st, you will have access to it, and you will see it just by looking at. You click on the overlay window, and then you will see using, for example, I have this thing. I share 400 giga. And I'm using 60 giga of 2,400 giga. So check it out on your status window. And if you don't see it, let us know. And we'll make sure that, you know, we deliver you what the offer is. Okay, what about the bandwidth? How much nodes do you need to achieve reasonable throughput? So, you know, how do we manage the bandwidth situation?
Yeah, so one more question linked to the performance issue we can face today. So basically, one of the property of peer-to-peer system is that you can download a file from multiple sources simultaneously, which is not the case when you are downloading files from a centralized system. Basically, the needed bandwidth depends actually on your hardware, and depends also on the internet access you have. What we are, as part of the improvements we are implementing right now, is the fact that we will have what we call multiple threads working on the download of a single file, on the upload of a single file. So today, I don't have any numbers to share with you on this topic, but the idea is to parallelize these actions in order to get much better user experience on this.
And which brings us to the performance matter that we discussed earlier on. There's another question about security. You know, are you planning to make deep security audits by external companies to commit to data security? We have so many examples of crypto so-called companies, but which are not safe. I can answer that question. Absolutely. You know, we first of all, we know that the best way to guarantee the trustworthiness of what we say is transparency, and ideally, you know, we will open source everything. We are not ready for it yet, but at one point, this is something that we are absolutely considering. Until then, we absolutely are going to, and actually we are already in discussions with that, bring third-party, reputable security audit companies to review everything about Hive, not only our code, but the whole security infrastructure that we need to have in order to be trustworthy of all this precious data of yours. So, and that is not going to be once, it has to happen on a very regular basis. My previous company, Symphony, was also very focused on security, and we used to have audits every year. And I'm happy to do actually more if that makes sense. We'll also make, black hat, white hat initiatives, and obviously we'll reward people as they find issues. I think from a security point of view, I'm just thinking that, there should be another topic for webinar because, we talked about post quantum encryption. We talked about the way we keep the data safe, but given some of the questions I see, I suggest, Antoine, that we add also a webinar on security. Okay, I'm going to take 2 more questions because I eventually need to say goodbye and let you go back to your Valentine's on this special day. How long the data is kept if I'm not accessing this data? Let's say I put my 10 files and I'm not accessing this data. How long this data is kept on Hive Drive? Antoine, you want to answer that?
I think we have defined lifetime durability to your data. As long as you share the corresponding capacity, we will keep your data live. So there's no time limit. And I think that is also a strength, when you put your data out there, to make sure that as long as you share the corresponding resources, your data will remain available.
And there was another question that somebody asked, which was like, for some enterprise customers, you need data to be, immutable for 15 years, right? And or 10 years, right? So we are definitely building up to that. I want to make sure that everybody knows that durability is an extremely important factor. And actually, it's one of the properties of this technology that we are using. By definition, swarm healing makes the data immutable. And in our previous webinar, we spent quite a bit of time to explain to the community how hard it is for us to actually delete data. And we had to really come up with some ways of doing so. Let me just see if there's one last question I like this one. The helper node or the super nodes should meet the storage node selection criteria set by a given user. How do you ensure that?
So can you repeat, David, please? How do you ensure
the helper nodes? Our helper nodes.
Yeah.
How do they meet the storage criteria given for a given user? So, if I am expecting an SLA from Hive, what do helper nodes do in order to ensure that? I think that's what the question is.
Okay, so basically we have a monitoring process on the network, and this monitoring process will score the nodes regardless whether these nodes are helper nodes or standard user nodes. And each node on the network has its own score, and this score is calculated based on its availability, the available resources in terms of storage space, in terms of bandwidth, in terms of latency, and different many criteria. And this score is actually used to is used in the peer selection, what we call the peer selection process, to be sure that the selected nodes meet the criteria of the requested storage.
I think that answers the question. Okay, there's one final question. I got to take it. Hi, David and team. What other services that your competitors are basically offering that you're going to do? And can you please share more about what's coming and to deliver an amazing and super UX that will make users stick for life to Hive? So, we should have Jakub there to talk to it. But so this first half of the year, we're going to deliver you the following use case that will be better and far more affordable and definitely more sustainable than any competitor in the market. So store your data in the cloud, access your data from other devices that you've stored on the cloud. So different platforms, not through a web page yet, but it will come in H2. Share this data with Hivers or non-Hivers, okay? And make this available on Windows, on Mac, on Android, on iOS. I think it's fair for me to say, I'm not wrong, that we'll be bringing peer-to-peer technology for storing and compute to mobile phones for the first time, I would say, commercially at a large scale to the public. And we are very excited about it. It's a very hard problem to solve, but we found a solution, and we are obviously bringing it up very soon. With that, I'm going to close the Q&A session, and there are 1 or 2 questions I have not been able to answer because of the time constraints. If you still have a question, please reach out to either hello@hivenet.com or david@hivenet.com or Antoine or Amin or Adnan, and we'll obviously take it forward with you. And please keep those questions coming. That's what really makes Hive what Hive is. It is your Hive. And so we have shared here our handles on different social media. I'm very active on LinkedIn, and a little bit less on Twitter, but mostly on LinkedIn. So feel free to also interact with us through social media. Thank you very much. Wishing you a wonderful, happy Valentine's Day. And until next time.